The recurrence relation is 14.7, 14.8. Okay. That is n minus 1. That's n plus 1 is equals to 2n over n into n. Is n minus 1x minus is n plus 1 equals to the n prime, which is just 2 d dx. Is this 2, and we want to get Laplace transform of j sub n from Laplace transform of j sub 0. I mean, there's also this assuming n is integer. Right? For integer, this Bessel function also has the property that the negative n and positive n, they are not linearly independent. So for integer n, I don't know whether this question requires that. I mean, this thing you have, but this is the property for n is integer. Okay, and I don't know whether that is. Let me see. Actually, I use this one. This is 20.8.11. We already have the Bessel transform of j sub 0. Yeah, that is in equation 20.182. Yeah, that might be an example in the textbook, right? 20.182. Yeah, in the exam, in a textbook example, we already have the Laplace transform of j sub 0. Yes, square meter. Right, and then for j sub 1, right? Then you can use probably you can use this, right? The second one, because so you write down the second one, j minus 1 minus j sub 1 equals to 2 j 0 prime. And j1 and j minus 1 related to each other by this one. So j for n is 1, so j sub minus 1 is minus of j sub 1. So the two are the same, right? So this is minus 2. So j minus j sub 1 is minus j sub 0 prime, right? And now you can do a Laplace transform. Laplace transform j sub 1 will be minus of s Laplace transform of j sub 0, and this should be minus of the initial condition of j sub 0 at 0, and you have minus sign already, so plus j sub 0 at 0, and j sub 0 at 0 is 1. Another fact that you might not know, this is 1. Okay, so this is 1 minus s over s. Okay, that is this one. This one. Then obviously you can keep doing that because now you can write down the next one. Next one is now we can do one more explicitly and see if we can find a root. So you want a j sub 2. So if n is 1, then it's j sub 0 minus j sub 2 equals the 2 j sub 1 prime. And do the same thing, the Laplace transform j sub 0 minus Laplace transform j sub 2 equals to 2s Laplace transform of j sub 1 and minus j sub 1, the initial condition, but all the j sub n at x equals 0 are 0. But this is 0, so all the j sub n 0 is 0. Is 1. Okay. Another fact that you so there are quite a lot of properties of Bessel function. So you don't have the other term over here. So the finally is Laplace transform of j is 2 is the solid Laplace transform of j is 0 minus 2s. 2s comes Laplace transform of j is 1. Okay, so you found this, and obviously you can substitute all this to you. So if you want the j sub 0 here, j sub 1 to here, and and then now you can do the general formula using just the second one. So just write it out explicitly. Laplace transform of j n plus 1 is Laplace transform of j n minus 1 and minus 2s Laplace transform j. So this becomes a recurrence formula for the Laplace transform, right? Because you already have, say, you have 0, 1, and 2 already worked out. So you just keep doing it, and then you can keep doing it and find a solution. I mean, you can calculate any n, days of n, but the to find the explicit formula, you need to probably need the induction, do some induction, assuming you can guess the final form. And let me just write down the. I mean, this part is if you just get to this, that should be enough. But if you know the answer or guess the answer, you can check that by induction. This is with the s square plus 1 minus s minus s to the n power divided by square root did I do the induction? No, no, I don't think I myself did the induction, but I forgot. I did that in my YouTube video. I remember I had a video. That's a function, the Laplace transform. But anyway, this is the answer. If you check by induction, probably you can check that. You know what I mean by induction, right? So assume this is right for say for this one and this one, and then you practice use this form, plug in this two, and then see whether this is given by this with n change to n plus one, n plus one, yeah. Yeah. You know what I'm saying what by induction. Okay, so if you like, you can check by this. I don't think even in my answer. Is that okay?